Yes, welcome back to EDUHUNT, IIT and NEET Foundation classes. This is Sukumar, your chemistry mentor. Let's continue the worksheet we are doing. Now question number 26. When Cl minus ions are converted to Cl2, chloride ions, Cl minus ions. When Cl minus ions, chloride ions are converted to Cl2, Cl minus ions converted to Cl2, the oxidation number of chlorine changes from, this is the question. See, Cl negative converted to Cl2. The point is, we know very well when there is an atom having charge, when atom is having charge, it means you can simply give the oxidation state by just looking at the charge. So, -1 is the charge. So, -1 oxidation state. Okay. So, when an atom is having charge, then charge is equal to oxidation number simply. Okay. Yes. And this is obviously this is the element group of similar atoms. When it is in elemental form, when an atom is in elemental form, oxidation number is 0. You know very well. So, -1 to 0, there is 1 unit change, right? So, the change in oxidation number is -1 to 0. That's question number 26. Now question number 27. What is the oxidation state of chlorine in hypochlorous acid? Hypochlorous acid. There is, see, there is oxy acids of chlorine like this. Oxy acids of chlorine. What are oxy acids of chlorine? Shall I give you? Yes. HOCl, HClO2, HClO3, HClO4. These are the important oxy acids of chlorine. Okay, they have their specific names also. This is hypochlorous. Okay, so don't bother or don't worry like sir, how do we know all this, sir? Yes, slowly you are going to study all this. You are going to become familiar with all these examples in your coming classes or in your higher studies, right? Yes. Hypochlorous acid. This is chlorous acid. This is chloric acid. Chloric acid, this is chlorous. This is perchloric acid. Okay, yes. The point is very clear that in all of them, if you look at the chlorine oxidation state is varying, like here chlorine is in +1 state. Here chlorine is in +3 state, here chlorine is in +5 state, and here chlorine is in +7, the highest oxidation state of that family. Okay, sir, how can you know that? You can calculate, you can take the oxidation state of chlorine X, like that regular method what we do, and you can do it by the structure also. So in the question is about hypochlorous acid, this one. And the structure of this hypochlorous acid is like this. So, compared to chlorine, oxygen is more electronegative. If you take, then for this bond, oxygen will get -1. For this bond, oxygen will get -1, -1, -1. So, oxidation state of oxygen here is -2. Obviously, chlorine is losing, right? So, chlorine is in +1 state. Like that you are going to determine. So, I'll give for better understanding, I'll explain one more example here also. Let me explain HClO4. Can I explain? Yes. See, chlorine, the valence electrons of chlorine 1, 2, 3, 4, 5, 6, 7. It is an oxy acid, right? All these are oxy acids. So, what is the special point regarding oxy acids? Acid means it will release H+. Acid means it will release H+. In oxy acid, the releasing H+ will be on OH, right? It in the form of OH. Like, see, this is the important part in oxyacids. Acid means, let us take protic acids. Protic acid means it can release H plus. But in oxyacids, what is the special point? That releasing H plus is actually present in the form of OH group, right? Yes. So this is the OH group. And if you want to draw the structure for HClO4, first of all, it is having 7 bonds like this. 7 bonds like this, and there is 4 oxygens, 1, 2, 3, 4, and there is 1 hydrogen which is supposed to be present in the form of OH because it is an oxyacid. Yes. Sir, you drawn this structure very well, sir. How can we draw, sir? Yes, that's what I trained you with the concept of Vesper theory, right? So if you forgot, if you are struggling to propose a structure to the given formula, please go back to those videos of chemical bonding, where in the concept of Vesper theory I have explained you how to propose a structure from the formula. Okay? Yes. Or simply you can determine oxidation state like this also. Let us take the oxidation state of chlorine as X. And you know hydrogen is in +1 state, so 1 + 1 for hydrogen plus the oxidation state of chlorine, let us take X, plus each oxygen is in -2, so there is 4 into 2 negative, so total equal to the charge present on the species, no charge right now, so 0. Now the X comes out to be, X here comes out to be +7. This is the usual way you are going to get the oxidation number of the underlined atom. Now here also +1, +2, +3, +4, +5, +6, +7. So by the structure, by the formula, in both ways you can determine the oxidation state of the underlined or targeted atom. Okay? Yes. So like this one. +1 state, that is the answer. So moving towards next question, question number 28. In the reaction NO2 minus, are you able to see that reaction clearly? NO2, I'll write here for you. NO2 negative plus OCl negative gives rise to NO3 negative plus Cl negative. Yes. In the reaction, the oxidation state of chlorine, okay, we are going to look by the options, yes, does not change, changes from +1 to -1, changes from -2 to -1, changes from 0 to -1. See here the oxygen state of nitrogen. See, we are going to determine the oxygen state of chlorine. Yes. So just now I determined the oxidation state of chlorine. In the 27th question, I determined the oxidation state of chlorine in this hypochlorous acid as +1, right? Now when this listen carefully, look at this. When this hypochlorous acid releases H plus, when this hypochlorous acid releases H plus, what happens? Remove H plus. Yes, you removed H plus. Now what you left with? See, when you remove a positive part from anything, you left with the negative part. So obviously, when you release this H as H plus, you left with OCl negative. So when I call this as hypochlorous acid, then what's the name of this conjugate base? You don't know what is conjugate base? Then forget it, no problem. So when you call this as hypochlorous acid, then what is this? Hypochlorite ion. Hypochlorite. So here the chlorine is in +1 state. Are you getting? Okay. From +1 to what happened to chlorine? So chlorine oxidation state changed from +1 to -1. So what is the change? It changes from +1 to -1. For me, second option is the correct option. Yes. Now, question number 29. M3 plus ion loses 3 electrons. Its oxidation number will be, see, it's very simple. When an atom is having charge like this, M3 plus, I told you several times, when an atom is having charge, then charge is equal to oxidation number. Simply, by looking at the charge, you can say the oxidation number. Okay. Now, it is an atom, let us say M, imaginary atom. It is having 3 units positive charge. It means it has already lost 3 electrons. It's practically, really it has lost 3 electrons. So, obviously its oxidation state is going to be plus 3, no doubt about it. Its oxidation state is going to be plus 3. Now, the question is saying that M3 plus ion loses 3 electrons more. Now it is losing 3 more electrons. Now what happens? You remove 3 electrons. Now 3 unit positive charge. See, if an atom loses 1 electron, it acquires 1 unit positive charge. If it loses 3 electrons, it acquires 3 unit positive charge. That's what happened here. Now again it lost 3 electrons. So again 3 unit positive charge. So a total of 6 plus. Now the oxidation state is going to be plus 6. Okay? Yes. Now, oxidation state of carbon is not 0. So you need to check the oxidation state of carbon is not 0 in which of the following options. See that. So the first one is the formaldehyde you are having. You are having formaldehyde here. You are having formaldehyde here. So plus 1. Oxygen is more electronegative than carbon. So plus 1 plus 2. Minus 1 minus 2. Overall oxidation state 0. You know that. And in the theory classes I have explained here. The oxidation state of carbon in glucose is going to be 0. It is 0. Why? There is 12 hydrogens plus 12. There is 6 oxygens. 6 into minus 2. Minus 12. So, plus 12 minus 12. The net oxidation state of carbon is going to be 0 because carbon is neither losing electrons, neither in the state of losing electrons or nor in the state of gaining electrons because it has associated with 12 hydrogen and 6 oxygens. Okay? Yes. Now here carbon dichloromethane, Cl, H, the same concept. Think by the electronegativity concept. So compared to carbon, compared to carbon, chlorine is more electronegative. So plus 1, so plus 2. And compared to carbon, we are considering hydrogen as a less electronegative, then minus 1, minus 2. So plus 1, plus 2, minus 1, minus 2. So plus 2, minus 2. 2 plus 2 minus, so 0. The last but not least, because this is the answer for us. Obviously, the fourth one is the answer, right? Single correct option. So this is the chloroform CHCl3. Then the oxidation state of carbon in chloroform is going to be plus 1, plus 2, plus 3, minus 1. Plus 3, minus 1. So it is going to be plus 2. So the oxidation state of carbon is not 0 in the fourth option. Moving towards next question. In ICl3, iodine trichloride I can call it as. In ICl3, the oxidation numbers of iodine and chlorine are, see, it's a interhalogen compound. Sir, what are interhalogen compounds, sir? Simply the name suggests the concept. The compound is formed between halogens. A halogen makes a bond with other halogen to form the compound. Interhalogen compound. So iodine, chlorine, interhalogen compound. Now you know very well among halogens, what are halogens? Fluorine, chlorine, bromine, iodine. You know very well in a group top to bottom electronegativity is going to decrease. Electronegativity is going to decrease, right? So compared to the element fluorine, chlorine is less electronegative. Or compared to bromine, chlorine is more electronegative. Compared to iodine, bromine is more electronegative. Compared to iodine, chlorine is more electronegative. So compared to the central atom, side atom is more electronegative. Okay, and try to draw the structure for it. Try to draw, you know very well how to draw the structure for given formula. Iodine is the 17th group element. All these members are going to have how many electrons in their valency shell? All these members are going to have 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Okay. Now try to make the bonds for the 3 chlorine side atoms. See, when halogen is a side atom, it can form only single bond. Yes, chlorine, 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 like this. Okay, I am not giving the shape. I don't concern with shape here. I am giving structure only. Lone pair, lone pair. So what is the oxidation state of central atom? +1, because compared to iodine, chlorine is more electronegative. +1, +2, +2, +3. So here iodine is in +3. I have given detailed explanation here. So in ICl3, the oxidation number of iodine and chlorine, iodine is +3, chlorine is -1. Iodine is +3, chlorine is -1. Okay, I think you understood. Yes, question number 32. The sum of oxidation number of the carbon atoms in CH3CHO, it is acetaldehyde. Let me explain. The formula will be like this: CH3CHO. I think you know about this functional group in organic chemistry, na? Yes, CH3 single bond CHO. Okay, okay. More expansion you need. C H H H single bond. How to expand aldehyde functional group? Yes. Okay. Now if you condense this structure, you will get this. Even more condensed. This is the most condensed. Okay. Now you can determine the oxidation state of each and every atom. So we are concerned about only central atom. Carbon, yes, +1, +2 oxygen for 2 oxygen bonds, +1, +2, and hydrogen bond you know very well, -1. And carbon-carbon bond gives nothing, right? Similar atoms bond gives nothing to the oxidation state. So +1, +2, -1, +2, -1, +1. So this carbon is in +1 state. This carbon is in +1 state. Yes. Now what about this carbon? Yes. -1, -2, -3, and carbon-carbon bond gives nothing. Yes. -1, -2, -3. This is in -3 state. Okay. Now think, what's the question? The sum of the oxidation numbers. We need the sum. -3 + 1, -2, right? -3 + 1. This is -2. The sum of the oxidation states of the carbon atoms in acetaldehyde, CH3CHO, -2. Yes. Which of the following have been arranged in the order of decreasing oxidation number of sulfur? See, we have given 4 options. In all the options, there are 4 compounds, and in every compound, the sulfur is the central atom. And we've been asked to find out, arrange in the order of decreasing oxidation number. Oxidation number, you got decreasing order. How? That means highest, you have to start with the highest oxidation number. See, sulfur, in the valence shell of sulfur, there is 6 electrons, right? The highest oxidation number for sulfur will be +6. Now here it start with +6. So this could be the answer. Here also, so see, don't take this SO2 plus, this is a print mistake. It is like SO2 plus written here, it is print mistake. So keep it, hold this second option. Let's think about the first, third and fourth option. +6. And here also, this is the peroxy, sorry, not peroxy, this is pyrosulfuric acid. So these 2 are going to be our answers. What about third option? In the third option, the first one is H2S. Hydrogen sulfide. In sulfide, sulfur is in -2 state, right? It is, sulfur belongs to oxygen family. The connections, the structure almost looks like water. not almost, it's like water. The structure is similar to water molecule like this, yeah. So minus 1, minus 2. Similarly, sulfur also minus 1, minus 2. Sulfur here is in minus 2 state. Yes, so this is not our answer. We hold this second option. Let's think about first and fourth option. Yes. Here sulfur, H2S, H2SO4, sulfur is in plus 6 state. We want the decreasing oxidation state. Okay, the oxidation states of the central atom in the decreasing order. That means highest to the lowest. Highest is the plus 6. Next, in SO2, it is very easy. Sulfur is in plus 4 state. In H2S, sulfur is in minus 2 state. In H2S2O8, sulfur is in plus 6 state. See, you don't know what is this H2S2O8. I have explained in theory videos. I have explained. I made a special video for some special oxidation states. There I explained about peroxy disulfuric acid. This is peroxy disulfuric acid. Here sulfur is in plus 6 state. So minus 2 after plus 6. So we need the decreasing order. So this is not correct. So this is not correct. If you hold the second option, then first option we need to check. This is pyrosulfuric acid. In pyrosulfuric acid, the oxidation state of central atom sulfur is plus 6 only. How I will explain? In the previous questions also, I think one of the previous questions, we came across this pyrosulfuric acid. In pyrosulfuric acid also, sulfur in plus 6. And this is the Na2S4O6 in a sodium tetrathionate. Sodium tetrathionate. Here sulfur is in 2.5 oxidation state. And this is thiosulfite, sodium thiosulfite. In sodium thiosulfite, sulfur is in plus 2 state. And S8, sulfur is octaatomic, whatever, octaatomic or whatever, it is in elemental form, group of similar atoms, so 0. So no need to check the second option, we got the answer because these are single correct options. So plus 6, 2.5, 2, 0. So this is so all the atoms are in decreasing oxidation number. So first option is the correct option. And obviously second option is also wrong because here sulfur is in plus 4 state. This is sulfite. In SO3, 2 negative, sulfur is in plus 4 state. And HSO4 minus, HSO4 negative, sulfur is in plus 6. So plus 4 after plus 6. That's not correct, na? Yes. So first option is the correct option. 34. Question number 34. The oxidation state of most electronegative atom in each of the product is. So what are the products you are having? Yes. One is hydrogen peroxide, other one is H2O. You know very well in hydrogen peroxide, in peroxide oxygen is in minus 1 state. In oxide, oxygen is in minus 2 state. So minus 1, minus 2, minus 1, minus 2, fourth option. Which reaction involves neither oxidation nor reduction? Yes. So this is the first point we are concerned about in this chapter, right? In the beginning. Okay, in the beginning I have told you several times very strongly that all the reactions are not redox. All the reactions are, in chemistry there are so many reactions, but all the reactions are not redox. So in this chapter it is our first task, important task to identify which reaction is redox or which is not. And I have given methods to identify which is redox reaction and which is not redox reaction. Yes. Here, this is chromate. This is chromate. In chromate, chromium is in plus 6 state. In dichromate also, chromium is in plus 6 state. In chromate and dichromate, both of them, in both, chromium is in plus 6 state. Sir, how, sir? Once give the structure, sir, if you ask me like that. Yes, I'll give. Chromium 1, 2, 3, 4, 5, 6, 7. Okay, there is 4 oxygen. Yes. Okay, if you try to propose the structure will be like this: CrO4, 2 negative. CrO4 2 negative. Sir, how to draw the structure, sir? Yes, revise the Vesper theory, chemical bonding chapter. In that chapter, I have explained and I trained very well how to draw the structure for any chemical species, whether it is ion or molecule. And this is Cr2O7 2 negative. So dichromate. See, dichromate will be like this. O minus. So let us take the acid part of that, like H. Then what is this as? Chromic acid, I can say H2CrO4. H2CrO4, like this one also. This one also, H2CrO4. Now imagine, I say imagine or assume if you have removed water from this, like OH from one species and H from another species. Imagine if you removed water from, then what happens? This chromium has lost this species, this atom or group. Then this chromium, this valency, this bond connected to that oxygen. This bond connected to that oxygen, because these two has gone like water. It's just an assumption to understand. Okay, now remove this, because you removed water, na? You remove all this part as H2O. Okay, yes. Now this connection is like this here. Yes. Okay, now it is H2CrO7, right? 1, 2, 3, 4, 5, 6, 7. H2CrO7. Now imagine this acid reacted with base sodium hydroxide. Then what happens? Salt will be formed. Salt means Na2. In the place of these hydrogens, you just write, in the place of these hydrogens, you write Na, right? ONA, right? Na plus O minus. So Na2, Cr2O7, or you can take potassium also, K2Cr2O7. That is famous. Even compared to sodium, potassium is famous. The name is potassium dichromate. So K2, you take K plus. So the name K2Cr2O7. Now structure is in front of you, and all of you are very intelligent enough to determine the oxidation state of chromium, right? Yes. +1, +2, +3, +4, +5, +6. +1, +2, +3, +4, +5, +6. Here, +1, +2, +3, +4, +5, +6. Okay? See, I am trying to explain how to determine the oxidation state of central atom by the structure, but there is more easy way to determine the oxidation state of central atom, just by the formula, na? But as a chance, with the help of this question, I got this question and I have a time to explain you as a chance, I am taking this question as a chance to explain the structure also. But you can simply determine how to determine the oxidation state like this. X plus 4 into -2 is equal to the charge present on the species -2. X comes out to be +6 directly. You can simply answer the question within fraction of seconds, like that one also. And we determine the oxidation state of chromium in dichromate in several times, right? In balancing redox reactions. Now, which of the following sequence is correct with the reference to the oxidation number of the iodine? Okay, 4 options. And there are, in all the options, the central atom is iodine only, and we need to find out the correct sequence. Sequence is correct, yes. Let me check see, my eyes gone on to that 4th option. HiO4 greater than ICl greater than I2 greater than Hi. I think this is our answer, because in HiO4, iodine is in +5 state, no, +7 state, right? Iodine is in +7 state. How, sir? Yes, hydrogen 1 plus iodine X plus 4 into 2 negative is equal to charge 0. So 1 plus X minus 8 is equal to 0, X comes out to be plus 7, yes, plus 7. And here ICL again, interhalogen compound, halogen combined with halogen, okay, fine. But compared to iodine, chlorine is more electronegative. So chlorine will be is in -1 state, iodine will be is in +1 state. And here elemental form, iodine is in 0 state. And in HI, compared to hydrogen, iodine is in more electronegative state. So iodine is in -1, right? So plus 7, plus 1, plus 7 to plus 1, oxidation number decreased, plus 1 to 0, decreased, 0 to -1, decreased. So that's the correct sequence. So that's okay. Here oxidation state of iodine is in -1, here it is 0. And option saying that compared to 0, iodine -1 state is more, that is wrong. No? 0 is more. Compared to -1, 0 is more, right? Yes. So 0 to -1, oxidation number decreased. -1 to 0, oxidation number increased. Yes. So fourth option is the correct option. Okay. See, this is second option is quite wrong because 0, iodine is in +1. Here iodine is in +7. Here iodine is in +1. And the option is saying that, this option is saying that the oxidation state of iodine in ICL is greater than this one. That means +1 greater than +7. No, na? Yes. The element which has only one oxidation state in its compounds, obviously fluorine. Fluorine is the most electronegative element in the periodic table. So when fluorine bonds with any atom in the periodic table in general, it will be in the state of getting one electron from the other atom. See, even with oxygen we know very well, when fluorine bonded with oxygen like this, in that case also you know very well oxygen is more electronegative, but fluorine is more electronegative than oxygen, so that's why it will be in -1 state, it will be in -1 state, -1, -1. So oxygen will be in +2 state. So fluorine is the atom, fluorine is the element which has only one oxidation state in its compounds. Okay? Yes. Thank you.